Okay. Part 4, give me one wing. Substitution. Part 6, give me another.
Elimination.
Elimination. Part 5, give me another.
Row operations.
Row operations with an augmented matrix. Part 2, give me the last one.
Inverses.
Not determinants, I'm not there quite yet. What do you do on the quiz in your problem set?
Inverses.
Our matrix equation, and we use the inverse matrix. Okay? 4 ways. 2 algebraically, 2 involving matrices. Here's our 5th way. We like options, right? Our 5th way is called Cramer's rule, and it basically uses all determinants to find the determinant. Okay, so Cramer's rule is used. We'll use the determinants to find the solution to a system of linear equations. This is not going to apply if the determinant of our coefficients is 0. We won't be able to use it. Okay. I'm going to explain how we find x, y, z, etc. It is going to make a lot more sense once we physically do this with numbers, so please be patient. Okay. First of all, each solution is going to look like this. We have a determinant divided by a determinant. That's what that D is standing for. Okay. Notice how when we're solving for x, our determinant has a subscript of x for our numerator. I'll tell you what that means. Okay. For each denominator, we have this D determinant. That is the determinant of the coefficient matrix. If we take the coefficient matrix, however big it is, and we find the determinant, that is the denominator for each of our variables. Now, don't write anything down until I have explained it. Okay? First of all, you may want to paraphrase it. Second of all, I don't want you to write and listen at the same time. Okay? The D sub x is the determinant of the coefficient matrix where the x column is replaced by the constants. Okay? What do I mean by, what are the constants in a system of equations? The numbers that don't have a variable. The numbers on the other side of the equal sign, right? Okay, so if we're solving for x, we're going to take the x column and replace it with those numbers and then find the determinant. If we're finding y, we're going to take those numbers and replace the y column and then find the determinant.
So do those constants still stay? So like if you replace it with the x column, do they still stay at the end? Or do they like kind of get rid of them?
Well, if we have a 2-variable system, we're going to make 2 2x2 matrices to find determinants for. Mm-hmm. So on the next slide, there's going to be a 3-variable system. I'd like you to write it down, and then we're going to go step by step finding x, y, and z. So that D is our denominator for x, y, and z. And that D stands for the determinant of a coefficient matrix. So I'm going to make a coefficient where, or I'm going to make a matrix where my entries are -1, 2, -3, 2, 0, 1, 3, -4, 4. I'm just taking the coefficients and writing them in order. So you notice that all of the first column represent x variables, all of the second column represents y's, etc. Okay. So go ahead and find me this determinant, please. Check your work with what I have up here. Okay, are we all getting 10? All right. So then what we're going to do to find x, our denominator is going to be 10, but our numerator is going to be the same 3 by 3 matrix, except we're going to take the x column and replace it with 1, 0, 2. See what I did there? Okay. So it's the same matrix, but I took these constants and replaced my x column. To save some time, since it's Wednesday and we have less of it, I'm going to go ahead and tell you that this determinant is 8. So we have 8 over 10, which is 4/5. That is just for x. To find y, we're going to do the same thing. Our denominator is 10. That's the determinant of the coefficient matrix. Then we're going to take this matrix and now take 1, 0, 2 and place it in the y column, leaving the other columns unchanged.
I have a question.
Yes.
Why would you want to do this way if it's like so much fun?
It's
It's just like, just a question, like, you know.
Some people may think that this way,
It's not more efficient, just more.
maybe it's less thought provoking. Okay, it's just a matter of multiply, 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 add. You know, whereas when you're trying to do row echelon form, you're really trying to like solve the big puzzle, right? Darby?
Couldn't you, if you wanted to plug in the x in the equation, it was only x and z,
So here's my thing with Cramer's rule. The whole point of Cramer's rule, or using matrices, is to avoid using algebra. So if you are doing Cramer's rule on a test, I expect 2 variables with a matrix, and then the third, if you plug them in, that's fine with me. Okay? But I want to see you use Cramer's rule as practice. But yes, on like an ACT situation, definitely would be a good way to go. Okay? All right. To save time, we all practice finding 3x3 matrices. Okay, and we'll practice it enough. This determinant is negative 15 over 10. So y is negative 3 halves. And then lastly, for z, once again, we're going to have a denominator of 10. But this time, we are going to plug in 1, 0, 2 to our z column. I will go ahead and tell you that the determinant of that numerator is negative 16. And so z is negative 8/5. So the solution to our system is 4/5, negative 3 halves, negative 8/5. I want you to go ahead and imagine doing that with algebra. With fractions like that, it would get pretty messy. With determinants, yes, it may take some time to do all those calculations, but it's not overly strenuous, right? So I'll follow up again with Darby's questions. My expectation for the test. If you use Cramer's rule for a 3-variable system, I need to see Cramer's rule for 2 variables. If you plug it in to find the third, I'm not going to be upset. Okay? I will say that Cramer's rule will be an option for finding a 3-variable system. What would your other option be? Okay, row operations with an augmented matrix. Since we don't have a calculator, I mean, unless you teach yourself how to find a 3x3 inverse, you can't really use a matrix equation. Okay. All right, what else can we do with the determinants? Once we write this down, Miss Darby. Please write this down. After lunch, we will do the example. But we can find the area of a triangle using a determinant. If we know the coordinates of a triangle, then you can plug them in to this matrix with 1s in the third column, find the determinant, and multiply by plus or minus 1/2. Y plus or minus 1/2.
And if the determinant comes out negative, you want the area to be positive.
We want area to be positive. Is it possible to get a negative determinant?
Yes.
It sure is. If your determinant is negative, you would want to multiply by negative 1/2 to get positive area. If your determinant is positive, you multiply by positive 1/2. Go to lunch, come back, we'll do an example. Okay, so we all have this written down, correct? We are going to be given 3 points. 3 points make a triangle, right? Those coordinates go in here. It doesn't matter in which order you place the coordinates as long as it's xy1, xy1, xy1. Okay? Find the determinant, multiply it by either positive or negative 1/2.
When you say it doesn't matter what order, the x1 and y1 have to be the
Yeah, the xy needs to be in the same row. Yes. But if you put, it doesn't matter which order the coordinates get placed. Is that clear? Okay. Fabulous. So, go ahead and write down these three coordinates. Okay, so our area is plus or minus 1/2. We're just going to put these coordinates in x, y, third column of 1. X, y, third column of 1. X, y, third column of 1. Okay. So now we will find the determinant. So go ahead and copy paste your first two rows. Okay, so our determinant. First diagonal is, hey, everybody, I need your help. What's our first diagonal?
2.
Plus. Plus. Thank you for your help. One more time. First up diagonal. Plus. Plus. 0. Okay. So our determinant is 8 minus 11, right? So what's our determinant? -3. If we want area to be positive, that means we're going to choose the -1/2. So our area is a positive 3/2 square units. If we're talking about area, we're talking about square units.
Watch me remember again. That's gonna be awesome.
Any questions? Okay. You give you 30 seconds to talk about this question with your pod. What would it mean if we plugged XY coordinates into this area formula and it gave us 0? What would that mean?
Minus 1 intersect and
Pod 6, what do you got for us?
No, it has no area.
It has no area. Okay, good. Other thoughts? How about I ask you this, Henry? Why would it have no area? How does a triangle have no area? Okay, there's something special about this.
Points could all be in a line.
Okay, if we don't have a triangle, it can't have area. Okay, so you're right, it doesn't have area because it's not a triangle. Okay, if this is 0, that means all three of our points are collinear. We can't draw a triangle. So that's our next piece of information. If we have this equal to 0, okay, this is the determinant from our area formula, then we know that our points are collinear, or they lie on the same line.
you should answer the UN. It's in this one.
It's, yeah.
You know, I don't lose my pumpkins,
And even though it's on, like, vibrate.
Yeah, because that way you find it even more.
credit.
Yeah.
It's from whoever has class with you on period. I don't know who it is. I'm sure maybe somebody could recognize the picture on the front, but we'll worry about that in a little bit. Okay.
At least it's not just an
Oh,
It
anything
is
will get
noisy.
And
On the next slide will be 3 points. We are going to determine if those 3 points are collinear. Okay? If that determinant is 0, our 3 points lie on the same line. If that determinant is not 0, we have a triangle. Those 3 points are not on the same line. Okay? So, go ahead and write these 3 points down. And we're trying to determine if they are collinear. You may want to include that. Are these collinear? Write the 3 points. If this were a question on the test, I would expect you to show me using a matrix. Okay? So you're going to make a 3 by 3 matrix of x, y, 1, x, y, 1, x, y, 1. And go ahead and find the determinant here. Okay, so our products, our down diagonals, we have -2 plus -14 plus 5. And we're going to subtract our up diagonals. 7, -10, and -2. Okay. This gives us -11 minus -5. Okay. So this determinant has a value of -6. Well, what does that mean? They are not collinear. Points are not collinear. Gabe, what would the value be if they were collinear?
What?
What would the value be if they were collinear? 0. Last order of business. Okay? If we have 2 coordinates in the xy plane, can we write the equation of a line?
Yes.
Okay. Typically, how have you done that?
You would find the 2 lines.
Find the slope.
And find the slope. Step.
Okay, then you plug in slope at a point, find y-intercept, and then you write it all together, right? Okay, it is possible for us to write the equation of a line with this fact right here. We know that if we plug 3 points into this matrix, if the determinant is 0, we have collinear points. So we're going to use that same idea. We'll plug 2 points in. Our third point will plug x, y in for a general point. And what will happen when we find a determinant is we get an equation in terms of x and y. We get the equation of a line.
Should definitely tell. The end of class can be like, it's in the songs.
I leave the class, but I'm gonna get to my last example, okay? Are you ready for an example? All right. Find the equation of a line passing through the points 2, 4, and -1, 3. On Friday's test, you will not use y equals mx plus b to find this. We are going to use matrices since we are in the matrix chapter. But then after chapter 8, you do what you wish. So, we know that if we put 3 points into this matrix, and they are collinear, the determinant is 0. Okay, so you have to have all of that. You have to put your points in the matrix, and we know that that determinant is 0. Okay? I'm going to go ahead and, I guess I should move this equals 0 over here. Okay. So to find the determinant, we copy paste the first 2 rows. Okay, now when you do this determinant, you're going to get variables in your products, and that's okay. So for our down diagonals, we get x times 4 times 1, 4x, plus y times 1 times -1, -y, plus 1 times 2 times 3, 6. Okay, minus the sum of our up diagonals, -1 times 4 times 1, plus 3 times 1 times x, plus 1 times 2 times y. And we know that that has to equal 0. From here, it's a matter of combining like terms. So we have 4x minus 3x, -y minus 2y, and 6 minus -4. So in standard form, x minus 3y equals -10. Yes.
You want it in standard form, not in standard form.
Right. Just keep it in standard form. Ax plus by equals c. That's enough. No need to solve for y. All right. Your last 10 minutes of class can be spent starting this assignment. I will make these reviews available. I'll just put them right here. I know that this is part of the mess up. I apologize. Oh, well, I can't let you do that. I'm really sorry. But if you would like to review, feel free to grab one. If you want to wait till tomorrow, no judgment. Okay. But for the last 9 minutes of class, you will be working on math of some fashion.
4.
Yes.